Hello, in this video I'm going to go over basic generators and motors and essentially what is AC and DC power. Okay, first I'm going to draw a little graph for you just to give you an explanation. Okay, so here's AC power, and this up here is the EMF, and this is time. I'm going to draw a quick little generator for you. These are two loops. Then over here we have a north and a south magnet. So essentially magnetic field is going across like that. And we have inside there a loop, which then comes out here. And what happens is there's two little prongs that come off this loop and basically spin. And then there's two little wires that come off, which come together to form a light bulb. I'm just going to use a light bulb as the easiest example. And this is essentially what an AC motor or generator looks like. So as this spins, this little loop spins in here, we know that there will be a current created because it's a loop spinning in a magnetic field, which then creates an EMF, which looks like this. Now it goes up and down because as it spins, when it's completely like here's the magnetic field lines, when it's like this, which is 90 degrees to it, it'll be at the maximum or minimum EMF. And then when it's completely flat to the field lines, the EMF will equal 0 because it's parallel to it, and we know from a previous example that that will be 0. Now, the maximum EMF is equal to the number of loops, or the number of loops in this loop inside the magnetic field, times the area of those loops, times the magnetic field, times the spinning velocity, or the angular velocity. Another way you can write this is that the magnetic flux in that loop is going to be equal to the magnetic field times the area times cosine. This will be the angular velocity times time. Remember, angular velocity is the change in degrees divided by the change in time. So if we multiply time, we'll just get the change in degrees. And you can clearly see that in this graph up here. So this is AC power. Now I'm going to wipe this all clean and show you another way. This is going to be in green, and this is DC power. Now I'm going to, again, use the graph. And draw a picture. Magnetic field lines. A loop goes through. And again, it's attached to a light bulb. Now in this case, we have something like this. This is because when you only have a single loop spinning, or a single loop back here, so we have a loop in here spinning, just like AC powered, and all the rules still apply, but inside here, we're not going to have a negative EMF. We're not going to have a negative EMF because as these two spin, and there's eventually, it's exactly parallel to the magnetic field lines. So here's the loop that we're talking about in here. completely parallel to the magnetic field lines, there'll be 0 EMF, so that 0 point is still right here. But since it's always spinning around, both are still spinning around this circle this way, and this way, let's say, we're going to have only positive changes in EMF, or only negative. It could also look like this. And as I said, that's because as it spins, it'll always be moving in the same direction, always clockwise, and not when you're spinning at the other. When you're spinning in AC power, you're going to have sometimes it's going around to the negative side of the circle instead of both just constantly moving, since these are 180 degrees to each other. Another quick thing is that the angular velocity is equal to 2 pi times the frequency, which the angular velocity is then divided by 2 pi is equal to frequency. If you're talking about, like, for example, a 60 watt, 100 watt bulb, you're talking about how many times it spins on that bulb, how many times you're going up and down the slope per second. And or not just a bulb, but any wiring. In the United States, it's 60 hertz, and there's 60 rotations per second, and in Europe, it's 50 hertz. Anyways, I hope this explains generators to you a bit, and I hope if you have any questions, feel free to comment, and I could make a new video explaining better if something is required of me. Thank you for your time, and I hope this helped.